Alright, this video might get a little bit lengthy. Try and do this all in one video in one take. So this is just going to be another example of one of our algebraic circle constructions, and we're going to do we're going to show something geometrically, and then we could do this for arbitrary values, and then show. Okay, so what are we trying to show? We're trying to show that M is well, first off, we want to find M, the midpoint between these two intersection points of this line and this circle. This circle is the unit circle, x squared plus y squared is equal to 1, and then I have this line, the formula for the line. So first off, we have to make sure that this line does intersect the circle, and it's not tangent, that it does have two intersection points. So that's going to be the first thing I do, is I'm going to find what P1 and P2 are. And then after I find that, then I can use those coordinate points to find M. And after I find the midpoint between P1 and P2 that lies on the line, these 2 points that lie on that line, once I find the midpoint, then I'm going to draw a segment from the center of the circle to the midpoint, and I want to show that that is perpendicular to our line, our original line. So first off, let's put that line in slope-intercept form. So that'll be y is equal to negative 7/4 x plus 2. All right. I was afraid this one was going to run out of dry erasing, so I'll just rewrite it with this one. Alright, so let's see. Y is equal to negative 7/4 x plus 2. Alright. So once I have this line in that form, then I can plug it in to this equation, x squared plus negative 7/4 x plus 2. Actually, I'm going to do it over here, right below this. X squared plus negative 7/4 x plus 2 squared is equal to 1. Alright, now when I square this, I'm going to have 49 over 16 x squared minus let's see, 7/4 times 2 is going to be just negative 7x plus 4 is equal to 1. Okay, so if I were to expand that, that's what it would look like in its polynomial form. So I still need to add x squared on there, and that's going to be 55 sixteenths x squared minus 7x plus 4 is equal to 1. Alright, from here I could complete the square, but throughout these videos I've realized that completing the square is not as easy as it's not as efficient as just memorizing that quadratic formula. So that I've changed my opinion. I think the quadratic formula is more efficient. So let's see. I wrote these down, and I'm just going to use what I wrote down because I don't know if I can talk and think at the same time. Alright, so 7 times 16 is 112, and 4 times 16 is 48. So I just put this in this form here. Oh, there's an x right there. Okay, and then we're going to use our quadratic formula. Well, x is equal to negative b, or in other words, 112, plus and minus the square root of 112 squared minus 4 times 65 times 48. Yeah, this is much easier than doing the whole algebra for completing the square every time. All over 2 times 65. Alright, let me make sure I did that right. 112 minus 4 times 68, 2 times 65. Good, perfect. Alright, so There's a little more algebra that's involved in this, but I'm going to skip the algebra because I don't feel like doing it. Because I'm feeling rather lazy. So this all boils down to be x. The two cases are x is equal to 12/13. And where did I write that other value? 4/5. X is equal to 4/5. All right, perfect. So now I have my two x values, and I should probably find my two y values that correspond to that. Oh, I actually have it over here, so I don't really feel like working it all out. So I'm going to call that x1 and that x2, and y1 is going to be, so in order to figure that out, I would just plug in that value into this equation and solve for y. So it's a little bit more algebra. But let's see if I can find the, let's see, that's 5/13 and 3/5. All right, so all this work and then a lot of invisible algebra there that I did not do, except on my own. So P1 is going to be this ordered pair 12/13 and 5/13. And then P2 is the ordered pair 4/5 and 3/5. Okay, so first step, we solve for y. We substitute in for the equation of a circle. That gives us, excuse me, if we're solving for x, that gives us the two x values. This x value here for P2, and then this x value here for P1. So we have x1 and x2. And we solve for y to get the coordinate points there. Alright, so let's see. And then the midpoint formula will follow from our equation, our two ordered pairs. So I'm going to go ahead and erase all this now that we've seen how to do that. Alright, perfect. Alright, so I'm going to call this M. Well, I've already labeled it M. So in order to find M, we're going to add up the two x values and divide it by 2. So I could, let's see, 1/2 times 12/13 plus 4/5. I'm going to write it like this. So 1/2 times that, and then 1/2 times 5/13 plus 3/5. And then imagine another parentheses there. I can't finish the whole thing. Okay, so this is just combining the fractions. We're going to have 12 times 5 plus 13 times 4 divided by 13 times 5. Multiply that by 1/2. And then combining these fractions, I have 25, or I'm sorry, I'll just 5 times 5 plus 13 times 3 divided by 13 times 5. And so I guess all the things I'm taking for granted here is that we know how to combine fractions that are added together in this way. And I'm also taking for granted well, a lot of algebra, obviously. Also, let's see, did I take anything else for granted? Knowledge that we would have. I don't think so, but because the whole point of this is to show that CM is perpendicular to L. And then we could do it arbitrarily if we were, and then that would be like more of a proof of it, but maybe I'll do that in a later video. It seems a lot more difficult than this though. And I did solve for the midpoint as well, so maybe I'll just grab those values real quick. Maybe I didn't. Okay, I didn't. So it's 56 over 65 and 32 over 65. And I'm sorry I'm not going to show this step-by-step, every step-by-step process here, because I think the videos are going to be really long, so maybe I'm not going as fast as I could. Okay, so I got the midpoint, and so actually I'm almost there. So once I have this midpoint, to find the slope of CM, in other words, the slope of that line, all I have to do is take this vertical distance from basically the y value of m and divide it by the x value of m. So I'm going to do that really quick. So what am I going to call this? I guess I'll call it m perpendicular. So the little case m, because m usually stands for slope, and I want the perpendicular slope to the line. So I just call it ML perpendicular or something like that. But I'll just call it M perpendicular. It doesn't really matter. So I take the y value of m, 32 divided by 65, and I'm dividing that by 56 divided by 65. And we'll see that 65, or 1 over 65 rather, divides itself out. So we have 32 divided by 56, which reduces, well, I'll probably put that. Let's see, that's 16 over 28, or 8 over 14, or 4 over 7. 4 over 7. And actually, I can see already that this is the right answer, because 4/7 will be perpendicular to the slope of that line. But let me show that real quick. So let me put that in slope-intercept form again. That line for L is y is equal to, remove the negative 7x divided by 4 plus 2. So negative 7/4 is the slope for L. And then from here, all I have to do is show that this is that 1 divided by m perpendicular is equal to the slope of line L. And I know that I use these little symbols a lot, but this is what I mean. I mean the slope of line L is negative 7/4. And the slope of the perpendicular CM is 4 divided by 7. So from there, it's pretty easy to see that CM is perpendicular to L. And actually this can be generalized. If we have any secant line, we take the midpoint of that secant line and we draw a line segment to the middle of that circle that is always going to be perpendicular to the slope of that secant line. So that we can generalize that, and that is a proof, a geometric proof. And I might, when I go back into more detail on this subject and subjects around this, I'll definitely cover that as well.